getting recorded, right?
Yes.
Yeah. So this is like we have to do complement of base 10 integer. So every non-integer will have a binary representation. For example, 5 can be represented as 101 and in binary 11 as this. Note that for except n equal to 0, there are no leading zeros in binary representation. The complement of binary representation is number in the binary we get while changing 1 to 0 and 0 to 1. The complement of the complement of 101 is in binary is 010. For given number n in the base 10, return the complement. So overall, we have to return the complement of a number in base 10. For 5, it's 101, and the complement of it will be 010 in binary, which is 2 base. 7 111 it is, 111, and complement is 00. Yeah. Same goes for 10. Yeah. So what would be the brute force here? Like, it's
Yeah. Brute force may be like something. Yeah, you can go to each and every bit, right?
okay.
And just look for it. If it's 1, then convert it to 0. Start from. Okay, I would say like brute force would be, start with first converting the integer value, okay, into a binary value and then store it in a string. And in the string, you start looking for the first, if you are starting from the start, you
Okay.
start looking for the 1 first, because if there are leading zeros, we just have to ignore them, right? So just ignore all of them and then come to the first 1. Then you change that to 0 and then correspondingly keep doing it for zeros to 1 and ones to 0 till the end of the string. And then convert the string back into an integer.
Yeah. So for converting binary, you're using a function or something like you'd be writing your own custom function for that.
Yeah, so we can actually take an integer value, then keep uh, using a modulo operation of 10 and finding what the remainder is, and then appending it to a string, okay, and then dividing by that integer with 10, and again keep on doing in a while loop till it goes to the end, right?
Yeah.
Till the integer num is actually not 0, is
Yeah.
0.
Yeah.
Yeah, and then you have a string, and then you convert that string to, you'll have to reverse it also, and then you actually change the ones to 0, zeros to 1, and then convert that string back into an integer.
Yeah. So you want to share like
No, this is just a brute force I was thinking about. Yeah, but the better would be like, yeah, you can actually use the bitwise operators, right?
yeah.
So that is one I would think of. Okay.
That will be more efficient.
Yeah, that would be more efficient. That's correct. Uh, so do
Some
you,
share.
yeah, guys have anything to share?
Yeah, so as Santosh said, if we do XOR of anything with 1, then that just negates the original bit.
Mm-hmm.
So I've used that approach only.
Okay. Yeah, no problem. Yeah, just go ahead.
Yeah, so that's what I said. That's all I have to say. I mean, that is the approach I used.
Okay.
Go to each bit and then XOR that bit with 1 and
Uh-huh.
store my answer somewhere.
So XORing will like if the number is same, then it will be 0, and if it is 0, then it will be 1, right? Like ones or 1 will be 0, and zeros or 1 will be 1.
Yeah.
So, but you are XORing with what?
One.
Previous one
No,
one.
no.
Sorry.
As I said, if you take any bit, say let's take XOR zero, XOR sorry, zero XOR one, so that would be one, and if you do one XOR one, that would be zero. So the original bit has been flipped.
Right. Yeah.
Okay. Yeah. You want to share?
Yeah.
Yeah. Sure.
Is it visible?
Yes.
Okay, so I've taken a mask. So let's take an example. Let's take 5. So this is my mask. And I've taken this this as a counter variable, this num. So basically, this tells me this takes me through all the bits, and this is what I'm doing logic wise. So n mask of this is going to be this 0 0 1 0 and
Again 0.
right. So this is my n after first iteration. Now in the second iteration, I've moved my mask to the right so that I can cater to uh, the left bit, like this bit. So now my mask is going to be 0 0 0 1 0. So this is my mask, and my n is this. N is this only 0 0 1 0 0. Okay. So I've moved my this num one bit to the right. So I have to now take the XOR of these two. So that would be 0 0 1 1 0. Am I doing it wrong somewhere? The answer
No.
should be
No, you actually are moving the mask also, right?
Exactly. Yeah.
yeah.
So your first mask when you were at 1, this last first and the last second bit, it should be 0, right?
Line number.
So you're if you are on line 28, okay,
Okay.
line 28, then last second should be 0.
This one.
Uh-huh.
No, that's correct. He's doing XOR of these two.
Yeah.
That's
So
Yeah,
because when your mask was at that, okay, yeah, here it is 0, yeah, and then 1 0, yeah, okay, you're right. So then go ahead, right? 1 0, okay,
Yeah,
should be 1.
this was my original mask,
Mhm.
and I after one iteration I've moved it to the left.
right. Right.
No, left, this side.
Oh, okay, this one. But then if you are moving it to the left, then that
Yeah.
is wrong. Then mask. You are.
No,
It will be like 0 1 0 1 0. It will be like this. Wait. Let me use the annotator. So it will be like. So you are moving. So it will be 0 1 0 1 when you move it to the left, because this bit will go that side, then this bit will be Oh, mask is this, right? This one is the mask.
Yeah, this one is the mask.
Okay, then that's correct. Sorry. I thought the other one, N is the mask.
No, actually, you see, when you are moving mask to the left, correct. So you are moving num also to the right.
No, I'm not disturbing none. N. Sorry, the N is what it is. So I think yeah, I'm going correct. I think so. This is my second iteration. This in the third iteration, my mask is uh, 001 00, and my N is the same.
Yeah.
00100. Now if I do no, it's this 110. Sorry, this one because I'm storing N in the. I mean I'm storing the answer in N only. So this is now if I do a XOR of this, I'll get 0 0 0 1
Oh,
3.
yeah. Okay, so you have to do it till the end of the num. Okay, so you are just moving the num to the end. Moving it
Now
that, yeah.
So the purpose of num is to get to know how many iterations are there, right?
Yeah, till the num doesn't become 0.
Yeah.
so
Okay. Okay.
here
Yeah, only so
we
he's
would
trying
have
to take
3
the first bit.
iterations.
Yeah, correct.
Yeah. So here we'll have 3 iterations because I've initialized num with N. So 3 times. So after the 3 times, it will become entirely 0. So this is our final answer. 2.
Right. Yeah. Yeah, this is good.
Okay.
Yeah, so I did something not so similar, but slightly more of a code. I'll quickly share that. So what I'm doing is I'm actually finding the mask actually first. Okay, so my mask is 1, and then I keep comparing the mask with the n. So if mask is lesser than n, I just shift the mask, that is because it's 1. I shift it again to the left. So I'm just shifting in terms of 2, right? So every time it is not, lesser than that, it keeps on shifting. So when it is greater, then I just stop there, get out of the loop, and just subtract 1 from it. So I will get all ones. So that is a normal mask what we do, right? So I'm just trying to find how many leading zeros are there. I just ignore them. I just take that mask and then complement n and then return it. But yeah, I'll be doing this while for a long time if my number is a bigger one.
So overall, it will be long and only operator, right? Time complexity.
No, actually, see, if the mask is almost 31 bits, right? So I'll be doing this while operation
Oh,
almost for 31
So what is
times,
this
right?
straight line doing? Mask equal to mask minus 1.
Yeah, so if I'm at any position, right? Suppose if I'm at this position, what is the bit, right? Is 1, 2, 3, 4, 8 bit, right? If it is 1, 2, 4, 8 bit. So, and if my number is 101, 101. So this is greater than that, right? This number. So if I do it, if I'm subtract 1 from it, it will be 0, 1, 1, 1. Right. So I'm getting a bit mask for that one. Bit mask for this number. So if my n is this, yeah.
101.
Yeah. So I just go and actually use this bit mask. So actually I'm ignoring all those leading zeros because of with the and actually those zeros will be nullified, right? And then I'm just using this 3 bits along with this 3 bits and then doing that AND operation with the complement of this one. So in order to actually ignore all the leading zeros.
yeah. And at last, and of those two mask and negative
Right.
number.
Yeah.
So your mask would always be this 111, right?
Yeah, I'm trying to make that as 111. It's a very simple way, or else I would have to create a mask by going for each and every bit, looking for it and ORing it either that way or this way. Both way works.
The code looks elegant, like very soft, like.
Sorry.
I mean, code looks very elegant. I'm saying, like within few lines, you have.
Yeah, it looks like, but I said like yes, if you have a bigger number, so it keeps on going for a long time.
Yeah.
Yeah, the leading zeros.
Yeah. Yeah, Shashank, what was your approach?
Yeah, mine was like this one. So I'm just converting it to binary first and ignoring the first two bits because you'll have 0 and B there, right?
Mm-hmm.
And those, pardon?
No, nothing. Go ahead. Yeah.
Yeah. And after that, this string, I mean, 1, I'm multiplying with whatever the length of that binary is. And out of that, I'm subtracting n from there to get to, I mean, because for getting the complement, we are subtracting that n in that, whatever integer we are having.
Shashank, I didn't understand this. What you said, 0B thing.
Yeah, this when you convert in Python, if you convert 5 to like 5 will be what? 8, 4 to 1. So it will be 0, 1, 0, 1, right? 5. So actually it comes like this 0b. When it goes to the bin function. So I need to discard those first two characters. These two characters.
Okay.
So that's what this slicing operation we are doing. And
Okay,
I'll get the length of this and those many number of ones I'll get and convert it to the integer. And then from that I'm subtracting the, what is it, this number.
So
So
you will get this after slicing, this 101, right?
Yeah, after slicing you will get.
Now the next thing you are doing is multiplying by 1.
We are calculating the length of this.
Okay, length of this, okay.
And then those many number of times I'm multiplying it with 1 and then converting it to integer.
Okay.
In base 2.
Oh, so you are forming something like a mask. In this case, if it is 5, you will have 4 ones, correct?
Yeah.
And then you subtract 111, which is 15 minus 5, correct?
Yeah. That will be.
Or is it like 7 minus 5? I think it should be 7 minus 5, right?
3 ones will be there, yes.
Yeah,
I mean,
so it will be 7.
Yeah. 7 minus 5, that is 2.
Hmm.
Yeah, actually I made extra 0 here.
This is something.
Yeah.
Subtracting this.
Pardon?
No, I was just thinking loud. Yeah.
So I have a question in Santosh's approach.
Mm-hmm.
So as you said, you will be going with one by one, taking as a mask till you reach the greater of that the given number, correct?
Mm-hmm.
So I also working around that, and it seems like if we can just jump it around with the 2 into something, 2 into that number, the mask, and then plus 1, that would also give us the same thing, and it will directly reach made us to reach over that greater number, that other than rather than going for like as you are subtracting it mask at the end, like when you reached 8 you have to subtract to match that number, like to 7.
Right.
So if we multiply by 2 and then adding 1, then it will be like, for example, if there is a if we have to reach greater than 5, it would be like 2 into like 3 into 2, our number would be 3 into 2 plus 6 plus 1, 7, and that would directly be 7.
Oh, yeah. I got your point. Yeah. That also makes sense. That is, in fact, optimized way of doing that.
Yes.
Right. So instead of going, I'm going ahead and coming back, right? But
Yeah.
you are actually coming to that point and stopping. Yeah, that makes
Yeah.
sense.
Yes. So and directly rather than going for 1 by 1, like multiply by 2, and then that number would directly plus 1.
Yeah, that works. Yeah.
Yeah.
You want to share your code?
I'm going back to my home. I'll
Oh,
just
okay.
in 5 minutes. That will be.
Okay, no problem. Yeah, Shashank. So yeah, this is a very different way what you're doing
Yeah,
in Python. Um, yeah, but does it pass all the test cases?
yeah, it passes all the test case.
Okay. Mhm.
It's like bin function is working, and
Okay. So
from that,
that bin function is actually converting a binary. Oh, it
yeah,
creates the
exactly.
binary
And
of that integer. Okay.
yeah, and you will get 0 b in front of it, so you need to get rid of that.
Hmm. So because you are doing a bin function and then you are calculating a len, right? So you are actually going for bin will be whatever the number of bits. That will be
Okay.
an operation of O of n. And then again, len will also be of O of n, correct?
And
Because you're going to
yes,
find that bit number. So because it will be converting it into the string sort of, right? Because you have to find a len, right?
yeah.
And then again, you are using int 1 multiplied by that number. So
Those many number of times one will
yeah,
be
so
there.
it is like O of 3n, something like that is time complexity.
Yeah, 3 passes will be there.
Okay.
First pass bin, second length, and third like converting those many ones to, I mean, those many number of times we are repeating once, and finally converting to, yeah, 3, and you can say.
Okay. I'm just trying to understand how it works.
Yeah, sure.
Yeah, no problem.
Daniel is asking to share your screen something in chat.
Yeah, actually, I wanted to check what Sonia has said. Like well, Santosh was explaining the code, my network cut, so I couldn't see that code. That's why. Like I saw the code, but I couldn't clearly see that. That's why.
Okay.
Yeah, so here is the code. So
Okay,
what
thank you.
she
Actually,
was saying,
yeah.
what she was saying, this whole pass, okay, the way I'm doing here, right, creating a mask. Instead of that, we could actually use something, like she's saying, whenever you are, uh, you should go through some while loop, right? And then if mask is lesser than n, maybe. Okay, I'm just trying to make it that way. So you would be doing mask multiplied by 2.
Oh,
Okay.
and at the end we'll be subtracting by 1.
No, and she was trying to even add 1, something like that, right?
Oh, okay,
Yeah.
okay, got
So
it.
if I do that, in fact, it should not be lesser than, yeah. If it is equal, also it will come out, right?
Yeah.
Yeah. And then actually I can use this. So something similar, because here I'm actually going ahead. Even if the while loop I'm trying to write on a single line, but actually it is going ahead one bit. Like if it is 2 raised to 3, it will go for 2 raised to 4 in this case, right? And then
Oh,
come
okay.
back. But here in this case, it's just going to go till 2 raised to 3 and then come out. So
Okay.
there
And
will be a slight optimization.
yeah, good. And what is that till 10? Is it complement then?
Yeah, that is
Instead of
complement.
this, we can directly take the XOR of mask and n as well. If
No, we can directly return till 10, right?
We need to take the XOR because we need to find
No, are we supposed
complement.
to use tilt here?
So if she is doing, then you can actually use a XOR. That is what it's saying.
Yeah, XOR.
Okay.
Yeah, this is the way which I was thinking. Yeah.
Yeah, something like return mask. And if you have a XOR of n. That should also
Okay,
work, but
got it.
yeah, but I think this might not be exactly the way it is. Okay, if it is 2 multiplied by 1, when I add that, or I don't know, or maybe something like mask, and then
Or
plus
mask left
mask,
shift
yeah,
2.
something like that, yeah.
Or mask left shift 1 plus 1. That is also fine.
Yeah, I don't think she is talking about left shifting, but yeah, this operation is
but
left shifting,
Yeah,
yeah.
instead of this plus mask, it should be like +1. You were
yeah,
doing right.
plus 1. Yeah,
Okay, so this should be fine, right? Yeah.
yeah, that is good.
And this actually you can have a left shift also, yeah, you're right.
Yeah, this is kind of a left shift only.
Right, yeah. That will work. Yep,
Yeah,
that's
got
good.
it.
Yeah. Overall, thank you.
Yeah, we can switch to next then.
Yeah.
Yeah, mirror reflection. So a special square room with mirrors on 4 walls except the southwest corner, and there are receptors which are numbered 0, 1 and 2. The square room will have a length of p, and laser from southwest corner will first meet the east wall at a distance of q from 0th receptor. So you are supposed to return the number of receptor that the ray meets first. So this is a wall with 4 sided with mirror, and this is your southwest corner, the one which is not numbered. So they are throwing laser from this side, and 2 is the receptor. So they are throwing from southwest. It's attacking this mirror 0, 1, and then reflecting it to the receptor. So they are telling the ray meets the receptor 2 first time. It gets reflected back to the left wall. The ray meets receptor 2. Okay. First time it gets reflected back to the left wall. Okay, yeah.
So here we have to just return the receptor number which the ray hits the first time, correct?
Yeah, only one receptor. Yeah.
Yeah, because if you hit that receptor again, it's going to reflect it somewhere. We are not actually concerned with that. We just see whenever it touches any of the receptor, we just return that number.
First time, yeah.
Yeah, first time, correct.
So here 2 they are hitting, right?
Yeah. So
And
he's hitting
next?
the 2. And why is hitting 2? Because your P is 2 and Q is 1, right? So it will form a sort of a triangle, right, which has anyway, it's equilateral triangle. Correct, because if it is 2 and then it is a midpoint, so that is the reason it will exactly go and hit the 2.
So this on the mirror 0, 1, it is hitting at the midpoint. That's why, right?
Yeah.
So
It doesn't have to be the midpoint every time.
No, it won't. Yeah.
it can.
Yeah.
But why 2 answer? Only one receptor it is hitting. No.
We want the number, no?
There's a number.
Yes.
2 is a number, receptor number.
It has
Return
to
the
return
number
the
of the
first
receptor. They are
receptor.
taking.
No, there's a
They're-
receptor number. They are numbered it like that 0, 1, and 2, right? 0 starts at the right bottom, and then 1 is the right top, and 2 is the top left, right?
Oh.
So those are the receptor numbers.
I got confused here. Return the number of receptors. So I mean,
Yeah,
they should have
initially, yeah, it looks like that. Yeah, I was also confused, but then looking at the example, it made clear.
Yeah, exactly. Makes sense. So what would be like here?
Well, this question itself is not so good question, I would say.
Yeah.
Yeah.
Yeah, I
was
didn't understand this question.
going
Right.
through this blog.
Yeah, there are so many theories, everyone actually explaining it.
What
Yeah.
they are saying, like they are first straightening the laser. I mean, the fold which you are getting here, they'll straighten it.
Okay, makes sense.
And after straightening it, they are using the property of similar triangles, like this equation x by p. X is the bigger bigger length. I mean, your bigger right angle triangle is this capital, X, Y, and the diagonal. Okay.
Mhm.
And smaller right angle is PQ1. But
Yeah.
again, it is okay.
No, yeah, actually, this is a very correct and good diagram what you're actually showing here. Yeah, this is
Yeah,
the
but
way you have to do it. So if your Q is lesser than the half of P, right? So it will
okay.
fall in only one row, I would say. Correct. So that would always hit. So we can have three different cases, right? One is if P and Q are same, okay, then we are always going to the ray is always going to hit the receptor one,
Yep.
right?
With respect to this diagram, you are telling.
Any diagram, if you take the first one also in the description, yeah. So if P and Q are same, it will always hit the receptor one.
Yeah, diagonally it will hit. Yes.
Right. So that is one case. Second case will be like if your Q is equal to or lesser than half of the P, it will
Then it will
always
hit P.
hit it will always hit the receptor 2.
Yeah.
And the otherwise it's going to hit the receptor 0.
Can you
Otherwise,
repeat
like Q is 0. If Q is 0.
No, actually Q will be more.
No, if Q is 0, then this will be parallel. The red line will be parallel to your zeroth
No,
line.
I take back my words. What I was saying is when I say Q is less than or equal to half, okay, that is one thing it's surely going to hit 2. But if Q is lesser than P and Q is still an even number, okay, then it will still go and hit 2.
Half you are telling this half, right? This point is half.
Yeah, that half. So
So
if
in
Q
this,
is still yeah lesser than that and still it is an even number, then it will always go and hit 2.
why even number? I didn't get.
I don't think it has to be an even number always.
If P is a very big number like 8 or something, that won't work, right?
Yeah, so if P is 4 and Q is 1, then also it will hit 2.
Mm-hmm.
But
P
how
is
you are
4.
deciding these numbers? Like,
So,
Yeah, actually, if you do it that way. Uh-huh.
so let's take this example only. So in this case, P is 2 and Q is 1. So this ray will hit 2 at the first time only. Like when it hits this left wall, it will hit only. So, and if this is one example. Now if my P is 4 and Q is 1, then it will hit on the second time.
Yeah. So, the way you are actually showing it there, right? Just hold on. I will just do the annotate for this one, what Harshit is describing. So if now P is 4, okay, and Q is 1. So in that
Yeah,
case, you will have 4 such these ones.
triangles.
Yeah, squares, right? Right. So this will be 1. So it will come here. This will be 2. This will be 3. And this will be 4. Right. And this will be 2. So because this is 1, this will be 2. This will be 1 and this will be 2. Right, Harshit?
Yeah, yeah.
So whenever actually your Q is lesser than half, you will have a single row like this, right? Or else if it is greater than half, you will have all these other things. What the other diagram you are showing, Shashank.
okay.
Okay.
But okay. So P is 4, then why 4? I didn't get why these 4 cells.
Okay, so this is a square, right? So it will be 4. This also is going to be 4, right? So this is always going to be a square, 4 by 4 square. And your Q is 1 here, right? So when you
Yeah.
go to the next stage, you have already crossed 1, okay? So this is being a square. So this is also going to be 1, right? So this 1 and 1
Yeah.
become, right? So here also you
Yeah.
have 1, right? So you already have crossed 2. So 2 plus 1 will be 3. And now you have only 1 remaining. So this is 1 and 4, 3. So this will be 4, correct? So therefore it will hit 2. Makes sense?
Mm, yeah,
No?
but I'm surprised like why you are spanning 4 squares. Like, I mean, why drawing 4 squares? That I didn't get.
Because on the fourth hit, it will reach 2.
Or else it will be like this. In this one, it will go like this, like this, like this, and like this, right? So instead of that, I'm actually showing in a different four
Okay,
square.
okay.
Yeah.
Oh. Yeah, 4 times. Okay, got it.
Yeah.
So you are enlarging it, I mean, expanding it and then presenting
Yes.
it.
The way you are actually showing the other diagram.
Yeah,
So
yeah,
you
yeah.
can actually do it in a single square also, but representation and actually understanding make more sense if you do it that way, right? Yeah.
Yeah, this one.
Yeah. Yeah. Actually you can remove this. Yeah.
Yeah, yeah.
But there are other cases when they say it is, yeah, this one. This one we are
So
discussing, correct?
if we want to make laser meet the receptor 0, so receptor 0 is like, oh, this one.
Okay, so they are talking about receptor 0. So how is that?
Uh, said something even number, they're telling the number of reflection has to be even in that case. Yeah, receptor is 0. That means the line has to be, the ray has to be exactly the length of P, right? Then only it can hit 0. I'm not sure.
Yeah, that I didn't get actually.
I mean, the ray has to be parallel to the length of a square, and Q should be 0. If Q is 0, then what do you say?
If Q is 0 in this case, in this case Q is not 0, right?
Yeah, here it is.
Q is maybe an odd number. If Q is an odd number, then actually it is going to the top and then actually it is returning back. So you can have your diagram also in this because it is going beyond one row. They are representing it in this way. You can have another row on top of it.
On the top of it.
Yeah.
Actually, this diagram is more easily understandable, I think.
Okay.
Yeah, because in this diagram, after the first, when the ray comes for the first time, it is reaching the second square. So maybe like when it comes for the next time, it is touching the 0, right? Wait, yeah, what is P and Q in this case?
P and Q. P and Q is a smaller triangle like this one.
No, he's asking what are the numbers of P and Q.
Oh, yeah, sorry.
For this example.
In that diagram.
Yeah.
Wall length P is the.
No, not that. And you showed a sequence of squares, right? Straight one.
I think you'll have to go down.
Like 4, 5 squares horizontally.
So I don't think so. They have
In
mentioned
this
any
one.
value
Okay.
for Q, P and Q. They haven't mentioned.
Okay.
But I think it might be an odd value.
Okay.
If it is even value, then I think it will always hit. Oh no, but Harshit actually explained that also. Yeah, I'm sorry. That is not right. Yeah.
I was trying to kind of obtain the
Yeah, this
possibility for each of those receptors because we have 4 options.
one.
So I mean I got stuck with that only.
Yeah, so actually they say, if you go down, Shashank, that is what their solution is, right? Yeah, this one. When you actually try to find out whichever of them, like the greatest divisor, just divide whatever the number you can divide, and then you find if it is odd and even, right? Something like that. And then based on that, actually they try to have different combinations. So if both are odd, it means that it will always hit 1. And if P is odd, and you have already, uh, you know, you have seen the condition where both of them are odd. So if you have P is odd, it means that Q is not odd in a case. Then in that case, it will always hit 0 or else it will hit 2.
No, but again, it looks like hard code. I mean,
Yeah. So I was not able to make sense of it, but I just saw one solution, and it looked very, yeah, the code was very simple. But then after looking at the code, I'm trying to relate using all these diagrams and to make sense out of it, why that solution actually is the correct one. Yeah, it's getting accepted. But if you draw this diagram, yeah, it might make more sense. Uh, but now I already have the code in hand, and therefore I started thinking in that direction. So that is not the correct way of doing it, right?
Yeah. I don't know under which category this maths category.
It's maths, yeah.
Yeah.
Maybe it can be explained in a different way. Can I draw here?
Sure.
Yeah.
Let me get out
Okay.
from here.
Okay. So sorry. Yeah. Can you see the square?
No, we don't see anything now.
Hello. Yeah. Oh, okay.
Yeah, this is correct. Yeah, we can see it now. Yeah.
Can you see?
Yes.
Yeah. Okay. I think it's. I'll draw it again in the set. So it's not. I think it's not. Wait, I'll draw manually. So this is the first square. So here it is 0, here it is 1, and here it is 2. Okay. Can you please take description? I can explain from there. That will be easier.
Okay. So what are you telling?
Yeah.
I have to draw. I didn't get you. Like. I think Daniel was right.
Yeah, Daniel. Or did it drop?
Yeah, it seems like maybe some issues.
No, he's there. I can see.
Yeah, he's there, but his mic is not visible. It means he has some problem in his mic. Okay. So
Yeah, might be. So like.
right. So Harshit was also having that, right? He explained about the 4 and 1, right? So
Yeah.
in that case, when what he said, if it is 4 and 1, okay, so it will reach 2, right? In that case.
Yeah.
1.
No, he said 2, right?
2.
Yeah.
Hello.
Who? James
Sorry,
is Daniel, right? Okay.
Yeah, I'm Daniel.
Okay, go ahead.
Yeah, my internet got cut in between.
No problem.
So yeah, okay. Can you please take the description? I can explain.
Sure.
Yeah, okay. So here, when the first ray started from the southwest corner, like each ray is traveling in horizontal direction for like it will be a diagonal actually. In horizontally, it will be always p, right? In every reflection. Every reflection it will be p, and vertically it will be q, like in every reflection. So we
You're
have
taking image from mirror, right?
Yeah, from southwest corner, imagine the southwest is 0, 0 in a graph. So currently it will reach a point PQ. Am I correct?
Okay, yeah.
Yeah, okay. So after the second reflection, the x-axis will be 0, like it will be back to 0. And the y-axis will be Q plus Q, that is 2Q. Am I correct?
No, it would be Q plus 2. No, right. Q plus Q, right.
Yeah, it will be the total distance traveled so far. By in y-axis, it will be 2Q. So like
Right.
if Q is, yeah, okay, imagine it is 2Q. So if it is crossing P, okay, we can assume that it is like it is having very good height, like it is going unlimited. Like above this, there can be another square. I'll just draw here. So imagine there is another square here. Can you
Yeah, I
see
have to
right?
draw. Okay.
Yeah. So and there are lots of square above this square. Like currently we are in square 1. So above this there can be another square, square number 2. Above that there can be another square, square number 3. Every squares will be of dimension p. So like after the first iteration, the ray will be in the right side, and after the second iteration, the ray will be in the left side. Like that, it will go. So like and in y-axis, it will be always incrementing by q. Am I correct?
In
Not
y-axis, it will.
not always, no, because so it is possible that after reflection from this left wall, it goes to the top wall.
Sorry, after, yeah.
So would that be an increment of y equal to q?
Like
So actually, yeah, that makes also sense, because if you have the square is like this also, right? You know, in this direction, then
Because y can never be greater than p, right?
no, what he's trying to say, I think maybe if I understand it correctly. So if this is P, right, and this is
yeah.
Q, when actually you actually if extend this again straight, right? So here it is Q, and in this case it will be 2Q, right? Okay, and if we again go to this something like this bigger, right, and if it is goes like this, so in that case it will be 4Q, because it is traveling these two also. So that way the y-axis will be increasing.
No, that is not what I actually mean. So fine, that is also.
If we look at the the constraint, the y coordinate can never be greater than p.
Yeah, like you can, if there are more squares above the square, we can like.
If y
This is
coordinate
first
is
square. So above this, there.
yeah, y coordinate can be greater than p, but then again it is going to get reflected, no? So even if it reaches like this, okay, if it reaches like this here, right? So in this case, y coordinate, so it will again start reflecting the other way, correct?
Yeah, like we had to like let us say that is x. X is the let us say the y. Initially, y will be q. So after the second ray, the y will be 2q. Then it will be 3q. Then it will be 4q. Like that, it will keep on increasing.
Yeah.
And we have to stop at a point where nq is divisible by p. Because when nq is divisible by p, it is at some end of the square.
Okay, but if nq is not divisible, then
it will be divisible at some point, right? So that is what given in the question. So like if y is divisible by p after third iteration, that means that it has reached the end of the third square. So
But
third
these are
square,
fixed quantities. I don't understand. Like,
sorry.
I think these are fixed quantities, right? P and Q.
Yeah.
So if they're not divisible, like if I say P is 17 and Q is 3,
Okay, you are
Okay.
saying that, okay, that is actually mentioned in the question. In question, it is said that it is guaranteed that the ray will meet the receptor eventually.
Okay, yeah. Multiple of Q can be divisible by P. Yeah, we are looking for that multiplier which
Yeah,
makes
like
Q
question will
divisible
be
by P.
like that only. Question will be, they will
Yeah,
give
got
the
it.
question like that. So always the NQ will be divisible by P. So in this case, the case where I told that this is square 1 and above this it will be square 2 and above that it will be square 3. If it is stopping at the end of square 3, that means that it is actually stopping at the top of square 1. Like if it is stopping at square 2, we can say that it is stopping at stopping at the bottom of first square, because second square is actually a reflection of the first square. Am I correct? Am I clear?
Yeah, actually, I trying to make sense.
Yeah.
So, one thing, like when you say that it stops at square 2, it has two options. Uh, Rather three
Yeah.
options.
If it is stopping at square 2, it it can be either in the southwest or it can be on southeast.
Either two
Uh,
or one, right?
yeah, southwest or southeast. If it is stopping at, like if it is stopping at even number of squares, it will be either southwest or southeast. If it is
Right.
stopping at odd number of square, it will be either northwest or northeast.
Yeah, and as the question says it's going to converge, so we have to
Yeah.
not consider any floating values there. Yeah. So nothing
Yeah.
between, yeah, makes sense.
So,
Can you
yeah.
repeat
So
for the odd square? Like, what did you say? It will stop at?
if it is stopping at odd square, like if it is stopping at odd square, we can it will be in northeast or northwest position. It will be stopping at either northeast or northwest, because currently we are at the end of first square. So if it is stopping at the end of second square, that means it is actually the bottom. It is the bottom of the original square, right? Because
Right.
above squares are actually the reflections of the first square.
Yeah.
So square one will be like when square one is tilted upwards, rotated upwards, it will become square two.
Right.
Got it? Yeah, square two is a reflection of square one, and square three is a reflection of square two. Like that, it will go.
Yeah.
Yeah. So it has to. It is in question. It is mentioned that it will touch either 0 or 1 or 2. So if it is stopping at odd number of square, we can. Sorry. If it is stopping at even number of square, we can confirm that it is in southeast. That is 0. Am I correct?
Come again, please.
Like okay. One second. Okay, wait. Okay, sorry.
So can
If
we
the
take some
number,
examples, like the first one we
yeah, yeah,
understood, P is equal to 2, Q is equal to 1. So
yeah.
now
Okay,
if
okay.
P is equal to 2 and Q is equal to 2, and then we take P is equal to 2 and Q is equal to 3, and P is
Yeah,
equal to 2 and Q is equal to 5, something like that.
yeah.
And
Okay,
then
we can take an example like P equal to 5 and Q equal to 2.
P is equal to 5 and Q is equal
So
to, okay, the odd and
yeah.
even.
So after the mm, like after the first iteration, the point will be at 1 5, right? Like y-axis, it will be, sorry, 5 1. It will be 5 1. That
Yep.
means it will be going 1 point upwards, and after
Okay.
second iteration it will
Five
be,
two, right?
yeah, sorry, 5 2, yeah. Initially it will be 5 2, then it will be 0 4, then it will be 5 6, then it will be 0 8, then it will be 5 10. Is it clear?
Okay, so 5, 10 means it's going to be at receptor 1.
Yeah, it will be at the end of the second square, right?
5, 10 is midpoint, right? I mean,
Is it midpoint or it is receptor 1?
No, 510 will be in the receptor 1. Yeah, it will be in receptor 1.
Okay.
So,
Yeah, 0.
sorry?
The 0th receptor, right?
No, first receptor.
First.
It will.
You're talking about which
Sorry,
square?
yes, zero. Yeah, sorry, zero. It will be in the second of second square. So it will be in zeroth receptor. Yeah, you are right. So,
2,
mm,
4. 4 will be the reverse one. Then you have 6. 6 will be the normal one. 8 will be the reverse one.
yeah.
And 10 will be the normal one, right? So if it is normal, is it not going to be 1?
So yeah, one of square 2
Well, okay, let's draw that.
and 0 of square 3.
Okay, can I erase this, Shashank?
I'll erase it.
Okay.
So I'm trying to draw squares here.
Oh, you're drawing it. Okay, go ahead.
Yeah. Okay.
Oh, he erased everything. Sorry.
Sorry.
No, I can.
It's okay. Oh, okay. Thank you. So initially it will be 0 here. Can you see the text as well?
Yeah.
Can you?
Yeah, the text here, what is drawing, yeah. 0,
I'm
1.
writing. Yeah. So 2, 0. Okay. So this is the case.
Mm-hmm.
So imagine the P is 5. The bottom
Yeah.
length is 5, like the base of the bottom square, that is 5, and Q is 2, as you said. So initially it will be like after the first try, it will be at some point like here. This will be it will be here
Right.
after the first try.
5,
So after the second, it will be here, and this is 4. Yeah, it will be 4, right? Yeah.
Yeah.
And then it will be here 6,
6, yeah.
then 8,
And 10.
then 10. Yeah, so this will be the
0 the receptor.
yeah, exactly. So maybe we can
Makes sense,
count the number of arrows. If the number of arrows is in this case it is 5. So if the number of arrows is an odd number, it will be in right side, and if it is even number, it will be in left side. So we can stop it when the count is divisible by p. So in this case, initially it was 2, right? The value of q was after the first try, it was 2 meters above the bottom. So after the second iteration, it was 4, that is 2q. Then it was 3q, then it was 4q, then it was 5q. We had to stop when nq is divisible by p.
Right.
Yeah, so when nq is divisible by p, we have to count the number of rays. So in this case, the number of rays is 5. So if it is odd number, that means it will be in the right side. If it is even number, it will be in left side. So if it is even number, we can directly assume that the answer is 2. But
Okay,
if
so
it is
you are counting the rays, number of rays, but that is slightly, that information is not available in P and Q, correct?
So if it is
yeah.
in case of odd, can you repeat it?
Yeah, in case it is odd, we
Like
have to,
here we
it should be either 0 or 1. If it is odd,
yeah.
it will be either 0 or 1. So how we can find that
So
is
how
like, yeah. So we'll be having NQ, right? NQ means it will be either in the either at the we have to check how many squares we have covered so far. So NQ by P will give you the number of squares we have covered, right? If we have covered even number of squares, it will be
NQ
0.
by
If
P.
NQ by P.
Okay.
So NQ by P will
Okay.
give you the number of squares we have covered. Am I clear?
Yeah, makes sense.
Yeah.
Yeah. So if we have covered even number of squares, then we are at 0 if it is right side.
Okay.
If it is odd
So if
number of
it
squares, we
comes
are at
odd,
1.
then 1 is okay.
Yeah. So first we have to we have to we have to keep on we have to take a variable y something, and we have to keep on adding q to that till nq is divisible by p. So I'll repeat once again. We are having a variable y. So initially it will be q. So we have to keep on incrementing, adding. Sorry, we have to keep on adding q to that till y is divisible by p. So when y is divisible by p, like along with that, we have to count how many times we have added. So if we have added it even number of times, according to this image, it will be in the left side. That is, it will be 2. If we have added it odd number of times, it can be either 1 or 0. So now we have to count the number of squares we have added. That is nq by p. So that with that we can check if it is 0 or 1. Is it clear?
Yeah. So basically, you're dividing this into two parts. First part is that if your NQ by P is an even number, then you say that it hits the receptor 2.
Yeah.
Otherwise, you check which square my final ray is stopping at. If it is stopping at an even square, then you're saying that it is going to hit receptor 0. And
Yes, exactly.
if it is stopping at an odd square, then it is hitting receptor 1.
Yeah, exactly.
Perfect.
Correct.
Yeah, man. That's a good one.
That's cool. Yeah. But then in this case, if P is odd, and then the case of when P equals even, so then it will slightly change, right?
Can you please give an example?
So like if P is 4, okay, and we do the same exercise for Q.
Okay.
If P is 4 and Q is 2, it will be fine. We understand it, right? It's going to be receptor 2.
Yeah.
But if P is 4 and Q is 3,
Okay, then
or if it is 1, okay. So I'm trying to say if it's an even or odd number, right? If P is even number and Q is an odd number, so
okay.
in that case it will be 0 or 1, and then we'll have to find out that way. Okay.
Yeah, let's take this example. P equal to 4 and Q equal to 3.
P is equal to 4 and Q equal to 3. So initially, okay, so I think it will be stopping at 12. So 3, 6, 9, 12.
3, 6, 9, 12.
I think it is stopping at receptor 2. It is coming 4 times, right?
It is coming 4 times. 4 3s are 12. So it is on the odd.
I'll just draw it. 3, 6, 9, 12. The red one is looking like 3, 6, 9, 12, right? Can you see that red line?
Yeah. 3 and then 6.
Yeah.
3 and 52. 9 and then 12. Okay. So then it is going to be at 2, receptor 2.
Yeah, exactly.
So if P is even, okay, can we make some assumption like if P is an even and Q is an odd, so it will always be receptor 2?
If we take 4 and 2.
Yeah, I think we can make that assumption.
Okay. So we have two things. One is if P is odd and Q is odd, it will be 1, receptor 1.
Yeah,
and P is even and Q is odd, then it is going to be always receptor 2, right? And if P is odd, okay, and Q is even, P is
Okay.
odd and Q is even, then it is going to be either the way we said, right? It will be receptor 0 always. And if P is odd and Q is also odd, then it is going to be receptor 1.
Yeah, actually,
That can be a truth table.
okay. Okay, let me think. I think so. I'm not sure. So if P is even and Q is odd, it will be definitely 2.
Right.
I agree that.
Yeah.
But other cases, like if both are odd, like if P is odd,
If P is odd
let
and
us
Q
say
is
P
odd, it is
like,
going to be 1 always. If
oh,
P
is
is
it?
odd and Q is odd, it will always be 1.
How do you say that?
Based on that, the one water solution I just got it from the discussion. So they say if P is odd and Q is odd, it is going to always hit receptor 1. Okay.
So will it be confusing if we go with the odd even truth table?
No, I understood the way you are saying, for
Yeah.
explaining and breaking down the problem, this is the perfect approach, right?
Okay.
Okay. Now, when you have to actually implement it, we need to have some test cases, right? So based on the test cases, we can
Okay.
actually go and implement. So I know this is the right way to go it, but I found an implementation which is already in the discussions. They have used this way. So I'm trying to correlate how can we, or else we can go your way. Okay. So how would you
Yeah,
like
anything's fine.
to,
Anything's fine.
Yeah,
how would you like to, implement it? Because we'll have to implement it, right?
Actually, I have coded it.
Okay, then let's go with that. Yeah, sure. Can you
Can I
share
show
the
the?
screen?
Yeah,
Yeah, sure.
sure, sure. I'll.
So Santosh, in your approach, you're trying to, fix all 4 test cases, right? Odd, even, odd. Even, odd.
Right.
Uh, What will be the answers?
Right. Yeah.
Okay.
Okay, so in that case, we don't have to go through the iterations, right? We can
Yeah, yeah.
directly. Okay,
But
okay.
that won't, it's not very intuitive. So yours is actually more intuitive.
Yeah.
Yeah.
Okay, so this is my solution. I'm having x equal to q initially, I equal to 1. So initially I'm assuming that I have finished the first iteration and x will be q. And I'll keep on incrementing x by, like I'll do x equal to x plus q every time and increment I by 1. And I'll do it till x is, like I'll stop it when x is not divisible by, like when x is divisible by p. So when x is divisible
Okay.
by p, I will stop it. At that time, first I will check the number of iterations. If the number of iterations is divisible by 2, I'll return 2.
Hmm.
And then I'll check x by p. X by p will give me the number of, will be giving which square I am in at the end. So if that is divisible by 2, I will return 0. Otherwise, I'll return 1.
Yeah.
Yeah.
So this I is for arrows, right?
Yeah,
Right.
yeah, number of arrows. Yeah.
Okay.
Yeah, but if
And X is for squares.
yeah, it is the
No.
distance traveled in the vertical direction, uh, like NQ.
Yeah,
NQ
yeah.
will be X.
Hmm.
So after 5 iterations, it will be 5Q.
Yes, got it.
Yeah, but I think if the odd even thing is giving a, like I didn't understand that completely till now. But if it is giving a of one solution, then that will be the best, right?
Yeah,
Like,
that might be,
so
but it's more easy
intuition
to
comes
understand.
from here only, right?
Yeah.
Then upon that, we are just mentioning the 4 conditions.
Yeah, yeah.
Yeah. That's a beautiful solution, I would say. So you're setting x to the value of q, and then you're setting I to the value of 1,
Mhm.
and I is nothing but the number of arrows. Okay.
Mm.
Whenever it hits an mirror, it's going to reflect. So that is what the I stands for. And then you keep on going in this while loop. I'm just thinking, you know, loud.
Yeah.
I'm trying
Yeah,
to
yeah,
go
sure,
through
sure.
your code. Yeah. So, and if x of modulo p, because we have to check if it is actually divisible by p, right?
Yeah.
So
Mm.
until we don't find that divisible value, we keep on going in this loop and keep on adding q, which makes perfectly sense, and also increasing the I because we are
Yeah.
increasing the number of arrows. And when we are out of that loop, we'll be out of the loop only when it is divisible by p, and then we just look if it is an first is like if it's an even number, we return always 2, right?
Yeah.
Or if your x by p, now x in this case is the nq,
Yeah, correct.
right? So if your nq uh, divided by p, okay,
Yeah, it will give the square which we are.
then okay, then you say modulo of 2. That I'm slightly not getting why we have to do that way.
It will give the number of squares we have covered so far.
Okay.
So NQ by P. So yeah.
Modulo 2 is okay, okay. Got it.
So if
It's
it is
for
this
checking
model
odd and
2,
even, right?
yeah, yeah,
Yeah,
yeah.
he's checking the first odd square or the even square in that case, right?
Okay, okay.
So
Yeah.
yeah, yeah. If we are in odd square or even square.
And then is differentially whether it's going to be 0 or 1. Yeah.
Yeah.
Yeah, I think this is a very beautiful solution. Yeah.
Yep. So basically, you are using the number of arrows to ascertain whether it's 2 or not, and you are using
Yeah.
the number of
Number of
squares
squares.
for
Yeah,
0.
exactly.
Yeah.
Yeah. So we're trying to go through all these diagrams, what Shashank was actually displaying there, right?
Yeah.
So yeah, and then this makes perfect sense. Now actually all the puzzles actually fall into place. Yeah. Yeah, good.
Daniel, please
Yeah.
share this code on Discord.
Yeah, please,
Yeah,
yeah.
Sorry.
very intuitive one.
Yep. Please
Yeah,
share this code.
I'll share it in the group. Yeah.
Yep. Thank you.
Okay. Can I stop the share?
Please, yeah.
Sure.
Yeah, sure.
Like,
Well, I'll quickly share mine,
Yeah,
So the
sure.
way it says, okay, what he's doing actually, he's trying to find, he's using a GCD. Okay, he's trying to find what is the GCD of P and Q, and then he's dividing P with that GCD value and getting trying to find whether it is an odd and even. So he's trying to see if P is 1 means it's an odd, and the same thing is doing for Q. And then it's like if P is odd and Q is odd, then you always return the first reflector. And if P equals 1, means P is odd in that case after doing the GCD stuff. So yeah, GCD actually the value can be even and odd also, right? So based on that, actually when you divide, you get the value. And then if it is 1, then you say either it is 0 or then it is 2. I was trying to make sense of this one.
So why
But
GCD? It is why we are
yeah,
calculating GCD?
he's trying to actually find if GCD is the same thing, right? If we are trying to go in number of squares, if you find which is a common factor of that, if you just remove it, so you are making the square slightly lesser in the
Okay.
smaller size.
Yeah.
Proportionately, you are decreasing the square
Then
size,
yes,
right?
number of squares. Yeah.
Because it's one and the same. And then trying to, but yeah, when you try to find a GCD, it's actually going in that while loop also what he's doing there. So I think it should come one and the same, or maybe recursion. It will consume more time. Yeah. Yeah, it's not so easy to understand. Therefore, I was trying to relate the way it is, Yeah.
GCD parsing also.
Yeah. So, but some things were slightly okay. Like if both are even, then it goes to 1. To some
Otherwise,
extent, we could make it. Yeah, but then when if it is P is odd, then how it is always going to 0, and then
0.
why? And then if P is not odd, so if P is odd here, it means Q has to be even. Then only you are going to come here, right?
Yeah, exactly.
Yeah. Or else then in this case it means that P is not odd at all. So P might be even, as well as Q might be even or odd. Then it will go to 2. So I was trying to find that relationship. Yeah. Okay.
Shall we move to next? Or
Yeah, looks like anyone has a
yeah.
question.
So this is like parsing a Boolean expression. The expression is as usual, like D stands for true, F stands for false. Not of expression. I mean, if expression is true, then not of true will be false, and the vice versa. Similarly, the AND expression will take AND of this and evaluate to the logical AND of two or more inner expressions. Again, take all the two or more expressions. Here, false is true, then false true will be true, false false, and here this will be false, and this will be also false, and all of them is again false.
Shashank, your voice is breaking.
Okay.
Now it's okay.
Okay. So like this will give you false, right? This portion will give you false, true, false, because AND operation is there. This will give you false, and all over them will give you false, false. And the expression will be a right expression will be representing a Boolean is given and
Still
the
the same.
pardon?
I was saying your voice was breaking. Now it's good.
Okay. So like so it's audible, right?
Now
So
it's fine.
how do we proceed here for brute force?
I think we can keep 2 stacks, one for the operators and another for the values. And then, so if we are starting the parenthesis, that means it is a new scope. Okay. Whenever we see a parenthesis being started, we know that whatever values are there inside until the closing parenthesis comes, the operation at the top of the op stack is active. So let us go and evaluate that whole stuff. So, and then put that value, that is atomic value. Let us put that at the value stack and continue like that. So what I'm saying is we'll have 2 stacks, one for operations, one for values. The values we will accumulate some values. For example, the operations, if it is ampersand, if it is and or, then there might be multiple values. So only when we come to the closing parenthesis, we know that there might be a bunch of values which need to be accumulated or kind of condensed into one value. Okay, so that is where we reduce it, and whatever one value it get reduced to, we push that back into the stack and then continue the same method until we come to the end of the expression.
So if
Yeah,
like we have,
I have tried with this approach only, as Rajendra is saying. Yeah, this is working.
But this is like an optimized approach, right?
Yeah.
I
thought
that is the brute force.
Okay.
No, I don't know.
Yeah, that's true. Yeah, because it's very difficult to come up with a brute force.
Brute
What about
force
this?
would be like you need to go one by one, and that would be difficult, like to to come up with, like, if there is a bracket inside a bracket, like we need to solve the inner part first and then move out.
Yeah, makes sense.
So by doing this, it will be
Yeah,
like,
so that is like Sonia said, so that nested parenthesis part, that is when stack comes handy,
yes.
because otherwise we'll be lost. How many levels deep we are, we don't even know.
Yeah.
Mhm.
So you are having two stacks. One stack, right? You said two stacks, right?
Yeah, one for the operations and one for the values. But the values one, so there is kind of, you can think of like this. So give me a second if I can write, annotate. Okay. So at this case, in this case, so the operation stack will have only one value, which is the ampersand, but the value stack will have two values. One is true, the other is false. Okay. And only when I come to processing the closing parenthesis, I know that I'll have to grab these two values and add this and apply this operation on these two values. Actually, this two is just a coincidence. It can be n actually, like the question says later. So what I'm saying is I need to have a demarcator. So I will use the same open parenthesis as a demarcator here. So when I come across the closing parenthesis, I will basically traverse through the stack in this direction until I come across this guy. So that is how I know the operation. This operation should be applied on this bunch of arguments.
Yeah, makes sense.
And then
Yeah.
obviously I have processed all this, the whole bunch. So I discard this value. Whatever value I got by computing this whole thing, I just push that onto the top of the value stack now. And I pop this guy also, the operation also, because that has been already used. Like that it goes. So now I'm ready for the next iteration or next level, so to say.
Yeah, and you pop the result, right, of this operation back in the
I put that back. Yes, I put that back. So where in the value stack where I had demarcated the beginning of the parenthesis, that is where I put the computed value of this over there.
right. So do you take these two parentheses off, or like
Yes,
you keep them?
I never put the closing parenthesis. That is kind of trigger
Right.
to start the computation.
Yeah.
The open parenthesis was there to demarcate the values from the scope.
Previous.
That was the scope demarcator or the depth demarcator.
Yeah,
So
you have reached that limit, and you
Yeah,
you don't
exactly.
need to go further. Yeah.
Yeah. So one thing I'm using here is I'm using JavaScript. The stack can contain a character as well as a Boolean, but that is a simple side work. You can simply keep T for true and F for false and then compute. So it is possible. So if you take the value array as a character array, that is also good. But in JavaScript, it allows any values. So sometimes I keep a character, sometimes I keep true or false.
And when you see a comma, you just move on, right?
Yeah, you just move
Yeah,
on.
it's continuing.
Right. Yep.
Yeah, that's good. So, but only thing is you are having two stacks, and that will be a sort of a bit extra space. But otherwise, time complexity is the most efficient, I would say.
Actually, the two stacks that I'm using, if you see at any given time, the total stack usage, if you combine both the stack usage, it will be order of n only. Because a operation only goes to the operation stack, not to the value stack. And the values only go to the value stack, not to the operation stack. So both of them combined will always be less than the length of the expression.
Yeah.
Yes.
but I understand it is an extra order of n requirement.
Yeah,
Space
because
requirement.
if you have an nested, okay, so you have operator negative, negation, and then you have a bracket inside that, and
Yeah.
and again you have a bracket
Yeah,
or and all
yeah.
that stuff.
So what I'm saying is basically there is order of n extra space I'm taking. Otherwise, it is all linear
Yeah, right.
in terms of execution.
Or else you cannot do it, either you use a stack or a recursion. Either of that you have to take care of, yeah.
Yes, correct.
Or else you do a complete string manipulation, you just parse the whole string with all those brackets and everything. A very lengthy way of doing it, right?
But
And you will have many passes.
But that parse will also use a stack, because that is where you have to keep stack of the depth, the nested depth. Like Sonia was saying, right?
No, what we can do is we can start with the string. Okay, we just traverse the string and find where are the nested ones, and just keep a count. And whenever there are nested, which are the deepest one, you mark that, and then next pass you just go and solve those things first. And again you come out, you decrement your count, yeah, something like that. But it is too many passes.
Not only because there is too much work also.
Yep.
So it will be difficult to implement, I would say.
Absolutely, yeah. Yeah, you want to share the code?
Yeah, I have coded it. Let me share it. Where is my? Give me a second, please.
Sure.
Okay, can you see my screen?
Yes.
Yeah.
Okay, so just a convenience function I have taken just to see what is at the top. Forget about that. So this is my main. So there are two main level of distinction I am making. One guy is handling the expression. It is traversing the expression. The other guy is the helper function, which is helping me evaluate the operations. So if you remember, okay, we'll come to that. So this is just a helper function. So either there are three operations given to us: not, and or. So the requirement for this function is basically takes an operator and a list of values and applies that operator on those values and returns only one value. That is all the signature it does. So for not, even though I have a list of values, there is only one value it can operate on. For ampersand, it starts with true, because that is the so to say, what is that called? That doesn't change that is kind of accumulator function, as you can see. So I'm starting with true, and then for each value, I'm basically doing the ampersand equals to, then returning the return value. The same for or, but I am starting with false, because false is the one which doesn't change that is the initial value. So after that, so this is just the helper function, but let us look at the function which is traversing the expression. Here I am splitting the expression because that way I can access individual characters. That is just a JavaScript requirement. If it is C or C++, we don't need it. I start with number 0, zeroth this thing. And this is just some kind of a check, but this is important. I have got two stacks, op stack and val stack. Both of them are empty. Now I traverse until I came to the end of the expression. If my current value, I'm based on the switching based on the current character. If it is one of the operators, that goes to the operation stack, op stack, and then breaks. When it breaks out from the switch statement, I just increment my index. As simple as that. After the operators are handled, these are the values possible. One is true or false or the delimiter. So if it is true, I'm just pushing the value true directly so that this guy will directly use it. But you can always keep it t and false and then handle it here. That is not a problem. Then, so this is the delimiter I pushed. The most important thing is happening when I see closing parenthesis, that is when the evaluation is triggered. So I need to calculate how many values are there where the last seen operation, the top of the operation stack, should operate on. That is when I am basically going back to the value stack, and until its top is the opening parenthesis, I basically pop those values from the value stack and populate my values. Those values will be later passed to the eval operation. And because I am checking until the top of the value stack is this, I need to throw that out also. Okay, so now I have got the operation at the top of the op stack and the values it should operate on. Once I have these two, of course, the eval operator will give me what is the total value, because I have also thrown away the top of the stack, so I don't need to do anything here. So at this point of time, I have removed the operation which was just now used. I have also removed the values from the value stack as well as the delimiter. So right now, all I need to do is basically push this value. This is just another value, right? The total condensed value from the operation gets pushed on the value stack. Now I am ready for the next operation or next depth or whatever. That's all. And at the end, it basically says whatever is at the top of the value stack is the return value.
But don't you have to check the other stack is empty or not?
Which stack? Oh, I am.
The operator stack.
It would be empty.
Other means the op stack.
Yeah.
Actually, I am assuming that this is a valid expression,
Okay.
so that's why I am not checking it. And it passed, by the way.
Yeah, no problem. It looks like, yeah.
Yeah, and so so answer to that is I assumed that it is a valid expression.
Right. And one more question. It's not a question actually. If you go slightly scroll up, I think it's a JavaScript. Yeah, just wait here. Yeah. So on line 21, you are actually pushing that expression which is an open, right? So
Actually, yeah, it is just this guy, correct?
that is a character, right? But
That
you
is
are also pushing true and false, which are the Boolean values. So JavaScript actually differentiates between a Boolean value and a char on its own.
Actually, JavaScript is type independent in this case because the stack can contain both character as well as a Boolean. That is what I was addressing. If it were C or C++, I would directly put the character here in the stack and handle that here.
Yeah, I have done in Python, and Python, though it use it stack is data type is independent, but I have added this T and F only, and I handled that situation while I am solving this.
Okay. Yeah. Probably that will also make these things very. So all these, so like these things became here, like that. These three can become just this, and then
yeah,
it will be true and false will be pushed here, and that needs to be handled here and here and here.
Yep, good.
That's all.
Yeah, I have done some kind of a similar using Python, and with different little bit cases I handled in different way, like
so if
but overall it's like of the similar, like two stacks, just do an operation when you have seen that closing bracket.
Yeah, the closing basically triggers the the operation.
And at the end, both those stacks would be empty, right?
Yes, it will be empty. Like in a value stack, like in the normal value stack, there would be the last value, which is evaluated value, which needs to be returned. which would be our answer.
Yeah, but there should not be any operations left. You
Yes.
must have exhausted the operation stack. That's correct. If something is not exhausted, that means we got the invalid expression to start with.
Shall I quickly share my code in Python? Similar.
Sure, sure.
Yes.
So in Rajan's solution, you are putting first operators and then the Boolean values. So if I put the Boolean first and then operator, like.
So is that a valid expression?
I mean that's a yeah. It could
don't
be valid
think
like
that will be valid
after
expression.
some.
So I don't think that will be a valid expression given the way they are giving the expression. If you are saying T, see, so what they are saying is the expression comes before anything else, and there are the operation comes before any values. If there is any value, there cannot be any expression any operation after that. Correct? Other than comma. And if there is a comma, that means it belongs to a parent operator.
Yeah.
Okay. Yeah.
So what I'm saying is, there cannot be a valid expression which reads like T and not F. It is not possible.
If it would be there, it would be in a bracket.
And the bracket should be preceded,
Like this.
Preceded by an operator only. Yeah, correct.
Yeah, like this. If it is in a comma, like this is an operand, but after that, after comma, this T is in a bracket if you have any kind of a operand before, like X, this is not sign is there.
Right. So the question what Shashank was raising, Shashank, are you trying to say, can we do this using one stack?
Yeah, one stack, using one stack also it can be done. I saw in some solutions.
Yeah. Looking at Rajendra's solution, I think, yeah, should be possible, right? But you'll have to take a lot of care about that.
Yes, exactly. Yeah.
Yeah,
I'll share it after this. So using one stack.
No problem.
Okay. So yeah, it is certainly possible. The only thing was it was keeping my abstraction very clear and separate. So one is value, one is
It's
operation.
very easy to understand in your case. Absolutely.
Yeah.
Yeah, similar as Rajendra said, I handle these two situations separately. Like if there's only T, then I'll just return true, and F, then just return false. And taking two stacks, one is for only expression, one is for the logical signs which we have. And I have started my loop, which is this. I started traversing my expression, and first of all, if I see any kind of this operator, I append that in my logical sign stack. And here, this would be else would be like all the like opening and F and T. I'll append that over in my this part. Because I added this because I don't want to add my comma in my stack, so I added that. I could have also done where like if expression is a comma, I just move ahead, but I thought this way would also be me. Same thing. And this would here I am making my main logic where whenever I see this as a closing bracket, first of all I pop my from the sign, whichever is the last one, like whichever is the last one, I'll just pop it. And here I'm, as Rajendra said, you can append to it over here. I am doing over here whenever I see when I'm popping from my expression stack as well. Whenever if I see T, I'll just put T true over here. Otherwise, it would be false. Here, one thing I'm making is like if there is exclamation like not sign, I'm handling it separately. Like it's just like you need to, if it is not value, like F, like the value which I have occurred, if not value is equal to false, then just append false over there. Otherwise, it would be true. Because I'm using this as a not over here, not like because I don't know if Python handles not, like I don't think so. It handles exclamation over here as a sign. So I put these instead of that. And otherwise, if it is or and, it will go over here, and as I'll just, it will traverse this stack until or unless it will see the starting bracket, and I'll pop out my value, whatever, and if the sign is or, then I'll be making value which was I already popped out, and then a new value, and I store that in this value again, because if it is again traversing this while loop, it would be again whatever the last value it has, it would wake with this current value which is popped, latest value which is popped from the stack. And at the end, I'll pop this because I want to remove this opening bracket as well. And I'll be adding whatever left as a value. If the value is true, I'll add that as a T, otherwise at a false, F. And at the end, I'll just pop and return if it is true, and otherwise it's false. Yeah, this is the one.
Yeah.
Yeah.
So you're not using two functions, but you are doing it in a single function.
Yeah, I'm doing in a single function, and I'm all the logic is over here.
Right. Yeah.
Yes.
Makes sense.
Yeah. This can be handled in a different way, but I handled over here the not sign.
Mm-hmm.
So I handled like this. It can be handled in so many ways, but I.
Right.
Okay.
Yeah, this is also easy to remember. Yeah.
Yeah, I found it easy, and the good part is I did it in a one shot.
Wow. Okay.
Yeah, so that was a good thing. Yeah.
You have to take a lot of care of conditions.
Mm-hmm.
Did someone try using recursion?
No, not me. Did you try?
I tried. I mean, I couldn't get through.
Okay.
Because, let's say we have a recursive function, and that returns me the final answer. But we can have two possible answers, right? Like if we have nested brackets, like two brackets inside a bigger bracket, then those two inside brackets would return their separate answers, and we'll have to take care of that. I mean, that would be my sub answer. So there would be two sub answers in that case.
Yeah, but even if it is nested, so what you could do is, you can remove your this operator, and then you are very sure, like the first starting bracket will be the last starting ending bracket, right? You're not going to have anything in between. So you can reduce your expression that way. The string, you can make a substring of that, the inner portion, and then again pass through the recursion. That should work.
And in call stack, it will be using.
Yeah, it will be using the call stack. You want to share your code, Arshad?
No, I don't have the recursive code.
Okay. No, I didn't try it at all. Yeah, actually, I was just looking for it, and I thought that the two stack, yeah, maybe, but I couldn't imagine much. So, yeah, thanks. Like both of them, Rajendra and Sonia, they shared their approaches. They were good, actually. Yeah. Shashank, you have then one thing, right? Yeah, the single stack.
Mine is like, I mean, it's almost same only, but rather than using stack for the, expressions, I'm using a string over here. So this is the stack, and this is the operator, and this is your previous value that I'm using. So I'm going through each of the expression and checking if it falls in either of and, not, or. I'll keep that operator. I'll store it in a separate, some variable. And the moment I find that I'm hitting this, so I'll start pushing them inside my previous, this none I'll be pushing, and that particular operand I'll be pushing in the stack. And then again, I'll initialize this previous to none. Then we'll be checking whether true or false. If the character is, then depending on the condition, if it is true, it will return true or else false. And then here I'll call a helper. I'll go through example that will be better. Let's say this is an expression and this is the operator, okay? And your previous is none. So initially you found the operator is what? Not. So to the operator I assign the not. And in the stack what I'll do, none, since you have after not you have encountered this what you say, open bracket, so I'll be pushing that particular operator into the stack along with this value previous as null. And after this once you have encountered this bracket, you will find false, and so your current value will be set to false. Now we got a helper function here in which I'll pass the previous value. So my previous value is none, and I'll pass the false operator. Helper function will do, it will go here and check your previous is none, and it will check what the top of the stack. Since the top of the stack is not here, right? Okay. So it's clear now?
Yeah, now it is.
Okay. So it will go to the helper and it will check what is the previous. So here my previous is none, and it will try to check what is the top of the stack. So, but here the top of the stack is not. So not of current it will do. So it will go to here and it is checking that the top of the stack is not. So whatever current I was having current as false. So not of false it will do, which you will get as true. And after that, you will encounter the closing bracket. So you don't need to go
Your
for.
voice is breaking in between.
Oh, is it now? I think net issues might be.
Yeah.
So am I audible loud now? Or
Like when you are explaining, the voice break. Otherwise, it will fun.
Whenever someone says your voice is breaking, you are clear again.
Yeah.
so, yeah.
Yeah, we understood most of it. Yeah.
So the only thing is, you are maintaining a recursion which would be going for a in call
This
stack.
is the helper function that I'm going.
Yeah. So it would. Oh.
I'm not maintaining it's not
Okay.
a question like
That you are calling the helper function. Okay, I thought it
exactly. So depending on various conditions, if the top of the stack is end, then we'll with the previous we'll do end of current. If the top of stack is not of this, else like.
So you are maintaining an operation as a string. Like all the operation would be
exactly
appended as a string.
String, yeah, this one.
So yeah, that can also be a doable. Like like how me and Rajendra were doing it. We are maintaining a stack. Instead of that, we can just maintaining a string as well, and that would be. But the size would be same.
Yeah, size should be.
Yeah, I think
size.
instead of stack, he's using a string. That makes sense. Yeah.
Yeah, that's the only difference. I think so. The
Or
memory.
should I say one expression? Yeah. What?
So I had this confusion. I didn't get Santosh clearly when he was explaining about the recursive approach. So Santosh, if we have this example and there are two nested strings and there's an outer string. So I have a recursive function which gives me the final result. That is one value. All right. So these two
This is
functions,
not valid, I think. You don't have any operator, right?
No, A is just expression. A is just a dummy expression.
Okay.
It's not a value.
Okay, see, whenever you have a bracket, you'll always have an operator in before that, right? So if you take an example 4, so if it's an valid expression, because that is what they are saying, it will always be a valid expression. So in that case, whenever you come for that in the example 4, you have an OR as an operator, and the first bracket is the opening bracket, and related to that opening bracket, the last one is a closing bracket, which is on the string, right?
Right.
So if you actually take that, okay, and then you actually decrement the stack, okay, and then you pass the inner part into a string, into another recursive call. So again, you start with the operator. Yeah. Sorry.
Inner part, you mean one expression, right? I mean,
Yeah.
from add till the TFT, right?
Right. Yeah. In that case, again, because when you start with an operator, either you look for the end of this one, or you'll have to look for another comma in between. Yeah, makes sense. Then you'll have to have two conditions there.
Yeah, okay. So these two inner operations like AND TFT and NOT of T will return their answers. That is cool.
Hmm.
Now this outer bracket will get two values, right?
Hmm. Yeah, in that case, you'll have to make some changes.
So
Hmm.
my function is designed to return just one value. So my sub problem is going to return me two values here.
Yeah, right. But there should be some way of finding, going through again. You'll have to parse it, right? Yeah, if they are at the same level.
Yeah, I'll have to see.
Hmm.
Yes, but that would be more optimized one, like recursion. If you
Not sure because it's going to use a call stack though.
Yeah, and the stack one was pretty good. What Rajendra and
Yeah, yeah.
Sonia.
But I've seen
That
some people using it, the recursive approach.
yeah, I wanted to go through one.
Yeah.
Go to it.
But yeah, the example 4 is slightly complex. And if you are able to break that, then I think other things are, yeah.
Yeah.
Okay, so if you start from the fresh, then yeah, this is the one, right? If you slightly go down, yeah, when it's doing a subs, yeah, see again looking for comma, and then he's looking for the closing bracket. Okay, but then yeah,
Is
so
this
we'll
the
have to take
version?
care of a lot of stuff.
it's
Yeah.
too big.
No, it is very big, yeah.
It's not ended. Oh, very big.
Yeah. Yeah.
Absolutely.
Right. Because the sub problem nature is like that can be multiple outputs.
Right.
Yeah, we'll have to take care of it. Yep.
No problem. Yeah.
So, so you can
Okay.
wrap it up
Let's
for
wrap it in. Yeah.
any other question.
Yeah, I know.